So first, we will recognize that the acceleration is moving down on this plane, and that we can find that it is parallel to mg sine theta. So I will write that acceleration is equal to mg sine theta. And with this, we can begin. So our velocity will equal 2 sine 2 times the gravity, sine theta, and the displacement. So we can plug in our values. 2, gravity is 10. Sine theta, it would be sine of 30, which is 1/2, times 3 because it traveled 3 meters. And we would get v squared equals 30. And then we'd find the square root of 30. So again, v equals the square root of 30. Now question B is asking to find the velocity when it arrives to the bottom of the inclined plane. However, we are given a friction force. So we have an object that is moving down, and we know that this direction is represented by mg sine theta, but this is the force of friction. And so if we want to find the sum of all the masses in the force of all the masses in the x direction, then we would look at mg sine, this being the positive direction. So it'd be positive mg sine theta. This is positive minus the force of friction, because it's going in the opposite direction, equals m times a in the x direction. Now the force of friction is nu by the normal. And the normal can be represented with this line. So if mg sine of theta represents this line, that would mean that this line could be represented as mg cosine theta. So if n is going in the positive direction and mg cosine theta could be considered the negative direction, we could write that the sum of these forces in the y direction, max, we know that in the y direction the acceleration is 0. It's not moving up or down. So the sum of f in the y direction, which would be mg cosine theta minus n, because they're going in the opposite direction, equals 0. And we could write n equals mg cosine theta. We could also write n minus mg cosine theta, but it would still come out to n equals mg cosine theta. So now that we have found n and we know that the friction force is un, we can plug it in here, and we would rewrite it as mg sine theta minus mg cosine theta. In this equation, the mass is not given, so it doesn't matter because we can cancel it out. And we would be left with g sine of theta minus g cosine theta equals acceleration. And now we can plug in our equation, our variables. So g is 10 times sine 30 minus u, which is 0.3 times 10 cosine 30. And if we were to plug that in our calculator, we would get 2.4. So the velocity, v final minus v initial, equals 2a times the displacement. So v squared equals 2.4 times 3. V squared equals 14.4. V equals square root of 14.